Okay, now let's look into the first type of this scheduling algorithm, which is first in, first out. So first in, first out, okay, is processed in sequential order. Okay, which one comes first? It will be service first. Okay, and this is fair to all processors. Okay, like I mentioned just now, fairness to of them all, and it approximates random scheduling in performance if there are many processors competing for the disk. Okay, which any this request comes first, it will be fulfilled first. Okay, first in, first out. Okay, for that, I would like to share, okay, how we want to calculate, okay, and differentiate the four disk scheduling algorithms. Okay, so I will first discuss on FIFO. Okay, FIFO. So let's say given a sequence of requested tracks. Okay, 55, 58, 39, 18, 90, 160, 150, 38, and 184. There are 9 requested tracks. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. 9 requested tracks. Okay, that need to be fulfilled. And the read-write head is currently at track 100. And it's in the direction of increasing track number. Okay, we just mentioned here. So first in, first out. So we mentioned here for each of the scheduling, we want to know what is the next track access and the number of tracks traversed. Okay, in order to get the seek time. Okay, in order to get the seek time. So let's start with FIFO, first in, first out. Okay, first in, first out is very easy. You just list out all the sequence by order, okay, by order. So, okay, I shall use, okay, this one. Okay, next track access, okay, the first one, after 100, okay, you mentioned here, okay, the read-write head is at track 100. You see here, track 100. So meaning that starts from 100, then it will continue to track number 55. Okay, 55, and then 58, right? And then 39, 18, 90, 160, 150, 38, and 184. Okay, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 tracks. Okay, so how to get the number of tracks traversed, meaning that the difference between one track to another. Okay, so the first part is you have to, right, the differentiate of the first track. Okay, it's 100. Okay, you get the difference between 100 and 55. Difference between 100 and 55 means that 100 minus 55, okay, 45. Okay, next, the difference between these two tracks is 3. Okay, whichever bigger, okay, we minus with the lower. Okay, 58 minus 55 is 3, the difference. Okay, 58 and 39, the difference is 19. Okay, 39 and 18, the difference is 21. 39 minus 18, 21. 90 and 18, okay, the difference is 72. So you have to calculate the differences between the tracks. Okay, so 90 and 160, the difference is 70. Okay, 160 and 150, difference is 10. 150 and 38, okay, you get the difference is 112. And finally, you minus 184 and 38 to get the difference, which is 146. Okay, so to get the total of number of tracks traversed, okay, you add up, sum up everything, you will get 498. Okay, 498. Add up everything. Okay, next we want to get the average. This is the total sick line, okay? Total sick line. So if you want to get the average sick line, okay, if you want to get the average sick line, you can simply divide this total sick line to 9 tracks. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 tracks. So 498 divided by 9. Okay, divide by 9. So you will get 55.3. Okay. Okay, this is to get the total, the average sick line. Okay, if dividing into numbers of tracks requested. Okay, if it does not give you any sick line, okay, if it does not give you any sick line, so so to get the average sick line, it's this way. Sometimes length is also known as time, okay, average sick time. So that is how to get the FIFO average sick length, 55.3. Okay, next for SSTF, shortest service time first. Okay, so we shall see the explanation of SSTF. So SSTF select the request that requires the least movement of the disk arm from its current position. Least movement meaning that is the shortest service time. So always choose the minimum seek time. Okay, possible starvation, right? Suppose requests constantly arrive for tracks between 100 and 1. So if you see from the graph here, there are basically 200 tracks numbers. So if a request constantly arrive for track 100 between 0, track between 100 and 1. Okay, if constantly arrive around here, okay, request there are more than that, okay, will starve. Okay, for example, like this, will starve. These are some of the requests that face starvation. So let's try calculate using SSTF algorithm. Okay, as we know, shortest service time first. So from 100, okay, from 100, okay, which of these sequence of request tracks have the least or minimum seek time? Okay, in terms of difference, okay, we get the smallest difference. Which of these will get smallest difference? Yeah? So it should be 90. Okay, 90, because 100 minus 90 is 10. Okay, the shortest seek time. So we will start with 90. 90. So after 90, which of these, okay, will get smallest seek time? Okay, after 90, it should be 58. Okay, 58. All right. So it's up to you to, if you want to list everything here, and then you can count, and you can count it later, or you want to do it all together, meaning that you immediately get the difference. 100 minus 90, 10. Okay, 90 minus 58 is 32. So after 58, the one that is nearest to the 58 is 55, where the difference is only 3. Okay, next, after 55, the nearest to 55 is 39. Okay, the difference is 16. Okay, next to 39 is 18. Yeah, 18. Sorry, it's not 39. You have 39, you also have 38. Okay, it should be 38. It should be 38, sorry. So again, 38. 38, difference is only 1. Okay, next, 38, 18. The difference is 20. Okay, if everything is already finished, we will go to the remaining tracks. So the remaining tracks should be 160, 150, and 184. Which one is the nearest? Okay, we'll get the shortest time. Okay, after 18. So it will be 150. 150, where the difference will be 132. Okay, 150 minus 18, 132. Next to 150, okay, is 160. Difference is 10. And finally, 184. Okay, 184, the difference is 24. Okay, to get the seek time, the total seek time, again, you add up everything. Okay, you add it up, and you will get 248. Okay, the total seek time, or total seek length. Okay, total seek length, 248. Okay, again, if average seek length is given to you, you can you can times with the given average seek length. But if it's not, then you can divide this with the number of tracks. So the average seek length or seek time is 248 divided by 9 equals to 27.5.